Look around you. Chances are a computer is nearby. Maybe you're reading this on one right now. It could be a laptop, a desktop, a tablet, or even the smartphone in your pocket. These devices have completely changed how we live. They connect us with friends and family across the globe. They help us learn new things, watch our favorite shows, and play incredible games. They are the tools we use for work, for creativity, and for exploring a universe of information. We depend on them so much. But have you ever stopped to think about how these amazing machines are actually made? It's a fascinating journey that starts with simple materials from the earth. The process of creating a computer is one of the most complex and incredible manufacturing stories in the world. It's a global effort. It involves thousands of people, highly advanced factories, and some seriously smart engineering. It's not just about screwing a few parts together. It's a precise dance of science and technology, where even the tiniest speck of dust can cause a problem. This journey transforms raw, basic elements like sand and metal into the powerful, sleek devices that we use every single day. So let's pull back the curtain and take a deep dive into the world of computer manufacturing. It's a story that's more exciting than you might think. Think about the speed and power packed into today's computers. A modern smartphone has more processing power than the computers that sent astronauts to the moon. That's mind-blowing. This power doesn't just appear out of nowhere. It's the result of decades of innovation and refinement in the manufacturing process. Each component, from the processor to the screen, is a marvel of engineering. Every step is carefully planned and executed to ensure that the final product is not only powerful, but also reliable and safe for you to use. This quest for better, faster, and smaller technology pushes the boundaries of what is possible every single year. So let's start this journey from the very beginning. We're not starting in a futuristic, shiny factory just yet. Instead, our story begins in mines and on beaches, where the fundamental ingredients for our digital world are found. We'll trace the path of these materials as they are purified, shaped, and transformed. We will see how they become the brains, the memory, and the heart of a computer. It's a tale of transformation, precision, and incredible scale. Get ready to see how a pile of sand and a chunk of metal become the magic box that connects our world. It's time to go inside. Every computer starts its life not in a lab, but deep within the earth. The raw materials are the essential building blocks for every single component. The most important ingredient is silicon, which is found in common sand and quartz. Silicon is what we use to make the computer's brain, the processor. Then you have metals like aluminum, which is used for the computer's case because it's strong but also very light. Copper is another key player. It's used for all the tiny wires and connections inside because it's great at conducting electricity. Gold is also used in small amounts on connectors because it doesn't rust and ensures a perfect connection. These materials are sourced from all over the planet. Mines in different countries work to extract these elements from the ground. It's a huge global operation just to gather the basic ingredients. Once these raw materials are mined, they are not ready to be used in a computer. They are full of impurities and other elements. So the next step is a massive cleaning process called refining. This involves heating the materials to very high temperatures and using chemical processes to separate the pure elements from the unwanted stuff. This purification is super important, especially for silicon, which needs to be incredibly pure to work correctly in a computer chip. Let's talk about that purity. For the silicon used in computer chips, we're talking about a level of purity that is almost hard to imagine. It needs to be 99.9999999% pure. This is often called 9 nines purity. To put that in perspective, if you had a giant box of 1 billion grains of sand, only one of those grains could be something other than silicon. This incredible standard is necessary because even a single foreign atom in the wrong place can ruin a microprocessor. Achieving this level of purity is a highly scientific and controlled process, turning simple sand into a material more valuable and refined than precious metals for the tech world. Beyond the main ingredients, there are also many other elements involved. You have plastics for keyboards and internal mounts, glass for the display screens, and even rare earth elements that help create the vibrant colors on your monitor. Each material is chosen for its specific properties: strength, conductivity, lightness, or ability to hold a charge. The logistics of gathering all these different materials from various corners of the world and bringing them to factories is a puzzle in itself. This global supply chain is the invisible foundation upon which the entire tech industry is built. A complex network that ensures every factory has the right parts at the right time. The journey from purified silicon to a working computer chip is where the real magic happens. It begins with melting the ultra-pure silicon in a crucible at a temperature of over 1,400 degrees Celsius. From this molten silicon, a massive single crystal is slowly pulled out. This crystal, called an ingot, is a perfectly structured cylinder-shaped log of pure silicon, often weighing over 100 kilograms. The structure of the atoms inside this crystal has to be absolutely perfect. This ingot is then sliced into very thin, perfectly flat discs called wafers. Each wafer is like a blank canvas, ready to be turned into hundreds of computer chips. These wafers are then sent to a special kind of factory called a fab, or fabrication plant. Fabs are some of the cleanest places on Earth, thousands of times cleaner than a hospital operating room. Workers have to wear special bunny suits to prevent even the smallest particle of dust, hair, or skin from contaminating the wafers. Inside the fab, the wafers go through a complex process of adding and removing layers of different materials to build tiny electrical switches called transistors. Billions of these transistors will be etched onto a single chip. This process, called photolithography, uses light to print the incredibly complex circuit design onto the wafer. The scale of this process is just staggering. A modern processor can have billions of transistors, and each one is incredibly small. We're talking about sizes measured in nanometers. A nanometer is 1/1,000,000th of a meter. To give you an idea, a single human hair is about 80,000 to 100,000 nanometers wide. The transistors being built on these chips are thousands of times smaller than that. This is why the cleanroom environment is so critical. A single speck of dust is like a giant boulder that could crush hundreds of these tiny transistors and ruin the entire chip. The process of building up the layers and etching the circuits is repeated hundreds of times for each wafer. Once all the layers are complete, the wafer looks like a grid of identical squares. Each square is a potential processor or memory chip. Now it's time for testing. A robotic probe tests each individual chip on the wafer to see if it works correctly. The chips that fail the test are marked with a drop of ink. Then, a diamond saw cuts the wafer into these individual chips, which are called dies. The good dies are selected and moved on to the next stage, which is packaging. The bad ones are discarded. From a single handful of sand, we now have the brains for hundreds of computers, each one a masterpiece of miniature engineering. While the processor is the brain, a computer needs a whole team of other components to function. One of the most important is the motherboard. The motherboard is a large printed circuit board, or PCB, that acts as the computer's central nervous system. It's the main platform where all the other components connect and talk to each other. The motherboard itself starts as a sheet of fiberglass, which is coated with copper. A design is then printed onto it. An acid is used to eat away the unwanted copper, leaving behind a network of tiny copper pathways called traces. These traces are the electrical highways that allow information to flow between the processor, memory, and other parts. Next up is the memory, or RAM, random access memory. RAM is the computer's short-term memory. It's where the computer holds the data it's actively working on. Think of it like your desk space. The more you have, the more projects you can have open at once without things getting slow. Memory chips are made in a similar way to processors, on silicon wafers, but they are designed specifically for storing information temporarily. These small black chips are then mounted onto a small circuit board to create a stick of RAM, which can be easily plugged into the motherboard. Storage drives, like hard disk drives or solid-state drives, provide the long-term memory where your files, photos, and software are kept even when the computer is off. Powering everything is the power supply unit, or PSU. This component is like the heart of the computer. It takes the high-voltage electricity from your wall outlet and converts it into the various lower voltages that the different parts of the computer need to operate safely. Building a good power supply is critical for the stability and longevity of the entire system. It needs to deliver clean, consistent power without any spikes or drops. Inside the PSU, you'll find transformers, capacitors, and cooling fans all working together to manage the flow of energy to the delicate electronics. Without it, none of the other high-tech parts would be able to do their jobs. Finally, you have all the other parts that allow you to interact with the computer. This includes the graphics card, which is a specialized processor for handling images and videos, making games and movies look amazing. There's also the case, or chassis, which is the metal and plastic box that protects all the internal components. And don't forget the keyboard, mouse, and monitor, the devices that let you give the computer commands and see the results. Each of these components is manufactured in its own specialized factory, often in different parts of the world, before they are all brought together for the final assembly. Now that we have all the individual parts, the motherboard, the processor, the RAM, the storage drives, and the power supply, it's time for them to meet. This happens in a massive assembly plant. These factories are a marvel of organization and efficiency, with long assembly lines staffed by both skilled workers and precise robots. The process is like putting together an incredibly complex puzzle, but it's done hundreds or thousands of times a day. The first step usually involves preparing the computer's case. The empty chassis moves down the line, ready to be filled with all the high-tech components that make it a computer. The first major component to be installed is typically the motherboard. A worker or a robotic arm carefully places the motherboard into the case and screws it into place. Next comes the brain, the CPU. Installing the CPU is a very delicate step. The worker opens a small lever on the motherboard's CPU socket, carefully aligns the processor using special markers, and gently places it in. The lever is then closed, locking the CPU securely in place. After the CPU is installed, a cooling system, which usually consists of a metal block called a heatsink and a fan, is mounted on top of it. This is crucial because, modern processors get very hot and need to be kept cool to work properly. With the CPU and its cooler in place, the other components follow in quick succession. The sticks of RAM are clicked into their designated slots on the motherboard. The storage drives, whether they are sleek SSDs or bulkier HDDs, are slid into their bays and connected to the motherboard with data and power cables. The graphics card, if the computer has one, is inserted into a special slot. The power supply unit is installed and its bundle of cables is carefully routed and plugged into the motherboard and other components. Cable management is important here, not just for looks, but to ensure good airflow inside the case to keep everything cool. The final steps on the assembly line involve closing everything up. The side panels of the case are put on and secured. At this point, the machine physically looks like a computer, but it's still just a box of parts. It doesn't have a soul yet. The next station is where the software is installed. The computer is powered on for the first time, and the operating system, like Windows, macOS, or Chrome OS, is loaded onto the storage drive. This process, often done on many computers at once, breathes life into the hardware. Once the software is installed, the computer is no longer just a collection of circuits, it's a functional tool, ready for the next critical stage testing. Building a computer is one thing, but making sure it works perfectly is another. After assembly, every single computer goes through a tough series of tests called quality control, or QC. This is like a final exam for the computer, and it has to pass with flying colors before it can be shipped to a customer. The first part of this process is often an automated burn-in test. The computers are placed on racks in a special room and are left running for several hours, sometimes even a full day. During this time, specialized software pushes the components to their limits, running complex calculations and tasks to simulate heavy use. The burn-in test is designed to catch any parts that are likely to fail early. If a component like the processor, RAM, or storage drive has a hidden defect, it will usually show up under this kind of stress. The temperature inside the testing room might even be raised to see how the computers handle heat. Computers that fail any part of the burn-in test are pulled from the line and sent to a repair station where technicians diagnose the problem and replace the faulty component. This rigorous testing ensures that the computer is stable and reliable for the end user. It's a crucial step to prevent customers from receiving a device that doesn't work right out of the box. Beyond the automated stress tests, there is also hands-on testing by human quality control inspectors. These inspectors check everything. They make sure all the ports, like USB and headphone jacks, are working correctly. They test the keyboard and trackpad on a laptop. They check the display for any dead pixels or color issues. They listen to the speakers and test the microphone. They also perform a physical inspection, looking for any scratches, dents, or gaps in the case. Nothing is overlooked. The goal is to ensure the customer experience is perfect from the moment they open the box. Safety is another huge part of the testing process. Computers have to meet strict safety standards in every country they are sold in. This involves testing the power supply to make sure it's safe and won't cause electrical shocks or fires. The computer is also tested for electromagnetic interference to ensure it doesn't disrupt other electronic devices around it. All these tests generate a lot of data, which manufacturers use to improve their designs and assembly processes over time. Only after a computer has passed every single one of these checks does it get the final stamp of approval and is cleared to move to the next stage packaging. Once a computer has passed all its tests and received the green light from quality control, it's ready to be prepared for its journey to a new home. The packaging process is more important than you might think. It's not just about putting the computer in a box. The packaging is scientifically designed to protect the delicate electronics from the bumps, drops, and vibrations that can happen during shipping. The first step is giving the computer a final clean and polish to make sure it looks perfect. Any protective films for the screen or shiny surfaces are applied at this stage. Next, the computer is placed into custom-fit protective material. This is often made of molded foam, cardboard, or inflatable plastic bags. This material is designed to suspend the computer in the center of the box and absorb any shocks from the outside. Think of it as a custom-made helmet and suit of armor for the device. The accessories, like the power cord, keyboard, and mouse, are placed in their own compartments within the box. The user manual and warranty information are also added. Everything has its specific place, designed to prevent parts from moving around and scratching each other during transit. The design of the box itself is a piece of engineering. It needs to be strong enough to be stacked in a warehouse or on a cargo pallet without being crushed. The cardboard is often double or triple-walled for extra strength. The outside of the box is printed with the brand's logo, the computer's model number, and important handling symbols like fragile or this way up. Sealing the box is the final step. Strong tape is applied to ensure the box stays securely closed throughout its entire journey, whether it's going across the country or across the world. After the computer is securely boxed, it is labeled with a unique serial number. This barcode is scanned, entering the computer into a global tracking system. This allows the manufacturer, the shipping company, and eventually the customer to know exactly where the computer is at all times. The boxes are then stacked onto large wooden platforms called pallets. These pallets are wrapped in plastic to keep the boxes together and provide another layer of protection. Using a forklift, these pallets are loaded into the back of a truck, ready to leave the factory and begin the next phase of their journey across the global logistics network. The journey of a computer from the factory to your desk is a masterclass in modern logistics. After being loaded onto trucks, the pallets of computers are taken to massive distribution hubs. These hubs can be located near airports or seaports, depending on their final destination. If the computers are being shipped to another continent, they are loaded into large metal shipping containers. These containers are then lifted by giant cranes onto cargo ships. A single cargo ship can carry thousands of these containers, which means tens of thousands of computers could be crossing the ocean on one vessel at any given time. This is the most common way to move large quantities of goods internationally. For faster delivery, especially for new product launches or custom orders, computers are often shipped by air freight. The pallets are loaded into the cargo hold of specially designed airplanes. While much more expensive than shipping by sea, air travel cuts the transit time from weeks down to just a few days. Throughout this journey, the tracking system is constantly updated. Scans are done at every major point: when the container is loaded onto a ship, when it arrives at a port, when it clears customs, and when it's loaded onto another truck for inland delivery. This complex system ensures that products don't get lost and that delivery estimates are as accurate as possible. Once the computers arrive in the destination country, they have to go through customs. This is where government officials check the shipment to make sure everything is legal and that all the necessary taxes and duties are paid. After clearing customs, the pallets are transported to a regional warehouse or distribution center. Here, the large shipments are broken down. The pallets are unwrapped and the individual boxes are sorted based on their final destination. Some might be headed to large retail stores, while others might be shipped directly to a customer who ordered online. The final leg of the journey is often called last mile delivery. This is when the individual computer box is handed over to a local delivery service, like a courier company or the postal service. The package is loaded onto a smaller delivery van and driven through your city or neighborhood. The delivery driver brings the package to your front door, and you finally receive the computer you've been waiting for. From the raw materials being mined from the earth to the final product arriving at your home, the computer has completed an incredible journey, passing through countless hands and crossing thousands of miles to get to you. And there you have it. The journey from a grain of sand to the powerful computer on your desk is nothing short of a modern miracle. It's a process that combines raw nature with the most advanced technology humanity has ever created. It's a symphony of creation, with thousands of people and machines playing their parts in perfect harmony across the entire globe. Every time you turn on your computer, you are activating a device that is the result of an immense, interconnected chain of innovation, precision, and hard work. It's easy to take for granted, but the story behind that screen is truly amazing. We've seen how basic elements are purified to an unbelievable degree. We've seen how billions of microscopic transistors are built on a tiny slice of silicon to create a brain. We've seen how a whole team of other components are manufactured and brought together on an assembly line that values both speed and care. Each step is a testament to human ingenuity. The entire process is a dance of incredible complexity, from the design of the circuits to the logistics of shipping the final product to every corner of the world. It's a system that is constantly evolving, always pushing to make things faster, smaller, and more powerful. This incredible process has a profound impact on our lives. These machines are not just tools for work or entertainment, they are windows to the world. They empower us to learn, to create, and to connect with each other in ways that were once science fiction. They help doctors save lives, scientists make new discoveries, and artists create new forms of expression. The manufacturing journey, as complex as it is what makes all of this possible. It puts this incredible power into the hands of millions of people, changing society and shaping our future in countless ways. So, the next time you sit down at your computer, take a moment to appreciate the journey it took to get to you. Think about the mines, the clean rooms, the factories, and the cargo ships. Think about the brilliant engineers, the skilled assembly workers, and the delivery drivers who all played a role. The device in front of you is more than just a piece of technology. It is a symbol of global collaboration and a remarkable achievement of modern manufacturing. It's a collection of earthly elements, transformed by human intelligence into a magic box that truly connects us all. And that, right there, is pretty awesome.